All right. Yeah, we are recording.
Cool. Okay. So, hello everybody. Welcome to this bi-weekly OpenWhisk community call, where we kind of talk about everything related to OpenWhisk and do some updates on the projects and hear about all the new cool stuff and new members and all that kind of stuff. I'll give everyone another couple of minutes to join. I'm sure there's going to be some stragglers. And then we'll go through the agenda today. We've got an hour at most. We don't have to use all of that, but that's how much time I've got. And I asked for some calls out on the mailing list and Slack and all that kind of stuff of things that people might like to talk about. And then we're going to cover over those things today. So I've kind of briefly given us a bit of an agenda to give us some structure, make sure that everyone gets time to contribute. We normally start with just doing some introductions and say hello to all the new members. And then if there are any new members, we call you out and ask you to kind of introduce yourself and kind of just say hello to the community and on what your interest is in OpenWhisk and, you know, what you've kind of been doing. That would be really useful. So I'll be calling you shortly. Normally then we do just project updates. So for each of the kind of core components, OpenWhisk is a big project. What's been going on, right? What's been going on in the core, in the release process with Kubernetes, the gateway, and just kind of an easy way for us all to keep up with the rapid pace of development. I know Tyson dutifully responded to my email on the mailing list asking to talk about concurrent activation, so we can kind of probably do that then. So we've got about 20 minutes. Normally Carlos is also here at some point and does quite a good job of some of the PRs that have been landing. And then Michelle's been working on a really awesome new feature around the Go and Swift runtimes to massively improve performance. So he's going to talk about that awesome work he's been doing, which I think has just landed, and he's got a little presentation. So I've given you 20 minutes to go through that. And then at 10 minutes at the end, we'll just do AOB, right? If anyone has anything else to talk about, then you can jump in then. And I've got one or two things. And then we need to find a volunteer for the next call. So next call will be in 2 weeks at the same time. And yeah, we need a moderator. And then we can kind of talk about that. So generally someone, it would be good if it was someone we hadn't had before. And if no one volunteers, then I'm going to start picking you, which is not what you want. So yeah, let's hopefully have some volunteers. Okay, so I think I've given enough time for stragglers, and I've kind of done the introduction. I'm just trying to look at the attendee list. We've got about like a dozen people. Is there anyone new in OpenWhisk who would just like to very quickly just say hello to the community and introduce yourselves? So if you are, is there anyone new there who wants to kind of briefly say hello? I might start, if I don't recognize your name, I might just call you out. So it's better that you volunteer yourself now rather than me embarrassing you in a minute.
Hey, so this is Dan Kelso. I've been involved with Apache Sling for a while, and I've been taking a look at OpenWhisk and specifically around some of the Java tooling. So hoping to get a little bit more time this week and on the next couple of weeks to introduce some new features there.
Awesome. Thank you. Thank you for coming forward. Moritz, I don't recognize your name, Moritz.
Yeah, I already joined 4 weeks ago. So
okay, cool.
Myself, I'm an intern at Adobe, and I'm working mostly using OpenWhisk as a user.
Cool.
But, yeah, let's see if it goes on after.
And then, sorry.
I'm sorry. Andy's new. I think I saw. I know he doesn't have video, but
he was next on my list of people to pick on. Andy, would you like to introduce yourself?
Hi, yeah, Andy here, also at Adobe, and working on our OpenWhisk projects, and so just joined a couple weeks ago and starting to get onboarded. That's it, pretty much.
Awesome. Well, welcome to everyone. Sorry if I haven't met you before, but it's really good to see some new community members kind of coming forward and growing the community. So if there's no one else, I'll be quiet for 10 seconds. Is there anyone else who would like to introduce themselves? All right, tumbleweeds. Okay, I think we've done that section. We can move on. So for the next kind of 20 minutes or so, or how long it kind of takes, we normally go around and do some kind of updates on different parts of the project. I'm normally looking, where's Carlos on the call? Carlos normally does a wonderful job of updating on things like core. Doesn't look like he's here for once. He also normally wears a really good hat, but
I'm here though. No video though.
No video. Yeah. Marcus, maybe I'm going to delegate to you. Could you give us 5 or 10 minutes or just 5 minutes on some notable changes that maybe are happening in core, and then I'll jump to Tyson, who can talk about concurrent activation stuff a bit more.
Yeah, I think I cannot fill 5 minutes, but I can briefly go through notable commits. So one of the more important bits, Christian has been committing a lot of performance tests to the core repo. We've chosen via the dev list to move the performance repo into the core repo because it's a fundamental part of OpenWhisk. So there are lots of different performance test cases and more to come there. What's notable as well? Another notable change was we introduced the notion of cluster discovery. So cluster orchestrators more and more become a first-class citizen in OpenWhisk, which is in this case needed for the load balancer clusters. So that got I think deploying on Mesos and Kubernetes a tad bit easier in terms of building a cluster there. Other than that, Chetan is continuing his work on artifact stores, which is an amazing and a huge bit of work. And Roderick got the first bits merged there short while ago. Other than that, I think that's been the most notable changes I'm aware of to the core repo. If anybody wants to add something.
Any other core stuff, or I'll page in Tyson and you can talk about concurrent activations. No, okay, that's good. So Tyson, do you want to talk about, for 5 minutes or so, do you want to talk about concurrent activations and some of the work you've been doing?
Yeah, sure. Let me share my screen. Oh,
let me stop. I'll stop sharing, and then you hopefully should share.
Let's see. All right, how's that?
Yeah, perfect.
So basically, just some background motivation. So some of the use cases that we're pursuing at Adobe have some throughput requirements where the tolerance for varied latency across a steady stream of activations is low, and when we have a mixed load of events coming from a lot of different sources, of course, things can get jumbled up in the system where suddenly you don't have warm containers based on the user activations that are getting to the system, steady throughput for some types of actions at least. And then secondary, being able to run fewer containers to operate with a larger load is always nice to run more with less. So there's a PR. I don't have a link in here, but it's a open PR.
Hey Tyson.
Yeah.
Sorry to interrupt. Can you switch to out of presenter mode? We're getting the presenter view.
Oh, drats. Why did it do that? We can just stick with this. Is that okay?
I can't see your screen anymore. I can just see you.
Oh. Okay. Oh. Good grief. Okay, I'm moving, shuffling screens around. Is that better?
I mean, that's fine. I think we can cope.
It's weird. It's like the screen sharing controls like jump to my other screen after I've
I think we'll be okay. Just get, you can,
Yeah.
we'll just suffer with your presenter notes. Yeah. Oh, go on. Yeah, that's good.
Okay. So the PR, let me bring this window over here so I can just show the PR real quick. I opened this PR a long time ago and have recently revisited it. So it's 2795, and there's a couple of broken tests still. So I need to work through that, but everything else is on track. So I just want to describe some basic fundamentals of the changes here. So the steps to achieving concurrency. So action image changes. So one of the things that currently exists in the Node.js action image is some preventative measures to make sure that you don't send concurrent requests to the action image. So there's a open PR to disable that state tracking in the Node.js action. And this assumes that the invoker will be wholly responsible for tracking the state of the action image and not have this kind of fail-safe in that image to stop processing if it encounters concurrent activations. I know Roderick mentioned that there's been some issues that have been found by using that. And it certainly would be possible to leave the state tracking in there. But just for simplicity, what I've done is removed it. I don't know if anybody has an opinion on trying to keep that state tracking in there as an optional feature. Please comment on the PR, and I can work on that. Otherwise, I would rather just take it out.
You could get away with it. It gets in the way.
Yeah. So the other thing that's interesting in the action image is when we start running concurrent activations, any log messages that are generated by the action suddenly become interleaved in the logs. And this is a little bit of a complicated problem. For this PR to introduce kind of a system level concurrency switch, it ignores that problem. So to deal with that problem for now, you need to either bring your own action image or disable log collection, and those are pretty big hammers. So that's not something that is anything that you would want to do for running in production right now. But just to keep the scope of problems limited for this initial enablement, I'm ignoring that for now. So in the tests that I've run lately, what I've been doing is disabling log collection. And for example, what we do at Adobe is basically effectively disable log collection from the invoker point of view and rely on external system for collecting logs that's enabled through the Docker driver, the Docker log driver. So aside from action image changes, the invoker changes are sort of minimal, and I just wanted to call out a few specific items just to give people a heads up. This is obviously in the PR if you want to look at the details.
Hey, Tyson, may I interrupt? It's Roderick again.
Sure.
In terms of the interleave logging, you could log the activation ID since it's available inside the action directly, right?
Sure. Yeah,
would that alleviate the problem, or are you referring to something else?
That would alleviate the problem. I think the implication there is currently Node.js is a good example where currently there's no structure, there's no enforcement of using a structured logging, and so adding the activation ID on every console.log message, for example. That's exactly what we're doing to enable our log collection to have the action ID per line in the log. But I don't know if that's something that everybody will want to do, or I think there's a couple of different approaches that might work, but that's definitely one of them, is to coerce the log output from the action to become structured, at least to have the activation ID in it.
Yeah, my 2 cents to this. I've been looking at this as well, in terms of the log thing at least. And from the data that I have from our production systems, it's clear that logging is a problem today. The more logs, the slower the system gets, and stuff like that. So I kind of would like to have the activation ID in the logs as well, so I can completely do that asynchronously of the container management. So let's pull that bit out. I'm fine with saying let's ignore the problem for the PR, but we should start a discussion on how to fix this, because I think it's very valuable for many deployments.
Yeah, sure. We've talked a bit about this internally, and the main question there is, do you continue to allow people to arbitrarily log to standard out with an unstructured format, or and then do you kind of behind the scenes hijack the standard out stream and coerce it to be formatted into a specific structure, or do you bubble up that structure directly to the action developer and say, if you want to log your output, you can't use console.log, you need to use logger.info, or some specific API to generate logs.
Yeah, right. Yeah, we should break the discussion out and put it separately on the dev list.
Yeah. So the invoker changes, just getting back there, one of them is to change the message feed, which is basically the buffer where messages are pulled off of Kafka and delivered into the container pool. And right now, the way this works in the PR is by trying to maximize the number of messages that's pulled from Kafka based on the maximum number of containers and the maximum concurrency setting. One thing that I've been thinking about is that we may want to make that slightly tunable to say that there's a factor by which that's reduced, so that if some containers are going to be supporting concurrency, or some actions are going to support concurrency and others are not, that we don't pull off 1,000 messages when there's only 10 of them that can be processed concurrently. So I think there's some potential additional changes here with the message feed handler capacity. For now, it's kind of maxed out based on the concurrency setting. And then the container pool has a general setting that's max concurrent. And what this directly affects is when a container is considered free versus busy. So the current behavior is any request into a container, the container is part of the busy pool, is moved from the free pool to the busy pool inside of container pool. So the behavior change there is that with the concurrent processing, the container remains in the free pool until it reaches the threshold of max concurrent, and that at that point it gets moved to the busy pool, and I won't be able to process any incoming activations. And then container proxy active activation count. This is a counter inside of container proxy to count how many concurrent activations are flowing through it. And where this comes up is the state changes, where the state changing from running to ready is different based on whether there's any remaining activations still in the container proxy. And then a kind of deep-rooted change is this the HTTP client that's in HTTP utils. So in order to efficiently have concurrent HTTP client requests going on, this has to be switched to be a multi-threaded connection manager. So there's one in the existing Apache HTTP client called Pooling HTTP Client Connection Manager. And so what this does is allows the container proxy to make concurrent HTTP requests to the same container. Without this, everything bogs down terribly. And the code that's in the HTTP utils basically enables this connection manager only when there's a value of max concurrent that's greater than 1. So if you leave it at 1, it will stay with the default connection manager that it sets up for you.
So Tyson, a thought on the pool manager. So just a bit of history. The reason that's using Apache HTTP client, that was one of the first implementations, and then we had tried switching to the Akka client at one point, and we had observed, at some various points that it would just deadlock, or the connection would just time out indefinitely. That was quite a while ago. I think some of those bugs we've observed separately and fixed in other parts, or Akka sort of by bumping its versions has fixed some of these problems. We could try to switch again and use the Akka client and its pool management, which would be consistent with the rest of the system, and just remove one other dependency, unless we're getting something custom out of the existing Apache client that is beneficial. Marcus might have something to say about that too, since he'd remember that.
Yeah, let's try to go down that route again, because I think the in terms of the threading model, that will fit us better than having a pool manager with separate threads and stuff. So let's try to get this to a non-blocking client again.
Yeah, in fact, I've had this conversation with Dan McWeeny, and he's on deck to research exactly that. He's out this week, but hopefully next week or soon after, he will pursue that. I was going to look at that potentially for this if I couldn't get any version of the Apache one to work, but this seems to be working enough. And so I was trying to limit the scope of this PR to avoid that for now, but yeah, I agree. So hopefully Dan will be able to look at that soon.
I think that's fine. As you just said, if the number is still set to 1 and we get the same behavior as today, I think that's fine, and even it's a good idea to limit the scope. We should do that separately as well.
Tyson, quick question here. Were you planning to also talk about the integer versus Boolean today, or not today?
So sort of. Maybe stay tuned. It'll come up very soon here. So what Dragos is getting at is should the question of should we have an integer value that says there's a limit and we track the number of activations at all, versus should we just have a Boolean that says if this is true, then all activations for a concurrent action will always get routed to the same container, regardless of the number of activations. So whether you want to support 10 concurrent activations or 10 million concurrent activations, they all use the same container, versus being able to say, I only want to support 10 per container. So there's a few questions that will come up in just a minute when we talk about. Right now, the current PR is a global switch that says there's a max concurrent value that's system-wide. The default is 1, and if you set it to 200, then it considers that all actions can run with 200 concurrent activations. And what I'll talk about in a minute is like how we should. I think nobody wants that for a long-term solution, and rather it needs to be on a per action basis. And so there's kind of another series of questions that's related to how we implement that as a per action configuration instead of a system setting. But before we get there, I also want to talk a little bit about the queuing behavior, because it may not be obvious exactly, well, if I change the message feed in the container pool, well, what does that mean exactly? So this is what it means. It means that in the worst case, where all activations are using unique actions, the result is that extra messages are peaked and held in memory while containers are busy for that invoker. And so what's the risk? Well, the risk is that if you are holding more messages in memory than you can process, then, just like today, anything that's in memory and unprocessed when the invoker crashes is lost. And so the increased risk there is that there's more messages lurking around in memory that would be lost if your invoker crashes. Now, the best case is that all activations are using the same action, and this is kind of jumping ahead in features, assuming that, well, let me just say, if all activations are the same action, then there's one container that can be reused for all of those activations, and the result is that all the messages are processed on a single warm container. There's no starting of additional containers based on the number of activations until you reach that max concurrent threshold. And the risk is the same, where any peaked messages that are unprocessed will be lost on crash, but they will be waiting for much less time if there's already a warm container. There's no container waiting going on, so there's no waiting for available container or starting up container wait time involved. So this is what I was getting at before, which was one thing that we can consider is changing the message peaking behavior to not be maxed out based on a calculation of maximum containers and maximum concurrent setting, but also have this other factor that's a concurrent peak ratio that says I have 12 maximum containers and 100 concurrent. So instead of peaking 1,200 messages, I want to only peak at most 600 messages to tune up the number of messages that might potentially get buffered in memory but still be unprocessed in the worst case scenario. Tests. This is one thing that's added as part of this pull request. There's throughput.sh is the existing work, the WRK tests. There's a new test which is async, and this is kind of where our use case comes up and where processing concurrent activations kind of shines, where you have a fabricated delay that emulates some downstream waiting. So if you consider an action that's executing an API request and returning a promise that will complete once the API responds, in our case, I'm setting the response delay to 175 milliseconds. So some example test results that we get with this is that with concurrent processing, we get 114 requests per second versus what we see on 5 with that same test is usually like 5 requests per second. And just running the basic throughput.sh synchronous tests, you can see like it's slightly better. It's not orders of magnitude better. So it was 60 requests per second versus 48 requests per second. And then I also ran tests with, instead of setting max concurrent equals 200, what if we set max concurrent equals 1? So we have effectively the same behavior of isolation today, but still with the concurrent processing enabled, but just setting the concurrency value to 1. We still get slightly better performance than what's on master. Now, of course, these tests vary every time you run it, and so your mileage may vary if you run it 5 times, you'll get 5 different results.
Can you explain why master is 4 times slower than max concurrent to 1? Is there a reason to that?
So no, I can't. I'm not sure.
Have these tests been running in a Travis environment, or
no,
are they on the local machine?
This is just running on my local machine.
Okay, gotcha.
It's possible it could be related to the well, no, I was going to say it could be related to the HTTP client, but that's been kind of disabled by the concurrency check greater than 1. I haven't figured out exactly why that's different.
Okay, it'd be nice to know. It could be the bigger look ahead. I'm not sure if the bigger buffer that you're peaking.
Oh yeah.
Sort of pipeline a bit more.
Would the buffer be bigger if max concurrent is set to 1? I thought the calculation was number of containers times max concurrent, which would be the same as today.
Yeah, that's true also.
So that's a little bit weird. Maybe you fixed another bottleneck there.
Is it disabling a blog, maybe?
Oh, yeah. It could be. Well, actually, no, because I've been running the master tests with logging disabled also.
Okay. Hey, sorry, can we, I just want to give you a couple of minute warning, so we make sure everything else gets in today.
Yep. Let me just breeze through the rest of this. So drawbacks, I just wanted to quickly call out known drawbacks. So potential for activation state leaks. So of course, this assumes that your actions do not do anything to maintain state across executions. Interleave logs, we've already discussed. So next steps, this is kind of the more interesting one. So how to go from having a system-wide setting that says max concurrency of 1 or 1,000 and change that instead to be a per action setting. So my kind of default approach for doing this would be to create an annotation. So one question that I would like feedback on is whether that sounds suitable from others' point of view. The nice things are, obviously, you don't have to change the Whisk client. The one thing that has me slightly conflicted about this is that there's currently some properties at the Whisk client and at the API level where there's limits that are kind of first-class properties, and they're treated as separate flags by the client. And this is a very limit-like setting, and so this kind of diverges from those existing limit settings like log limits, memory limits that you can set per action, and treats this one separately as an annotation. Once we have a action specific config, what I would do is leave the existing max concurrent in place as a system-wide maximum. If you want to put a limit on that, we can cap it somehow. And then action images. This is the logging issue, and there may be changes that people will want to have in action images in general. So just the bigger picture of what, if any, changes we should make to the images to support this. And then just some future ideas for kind of ongoing potential throughput performance increases. I think we don't have to go through this right now, but I think there's some ideas that we can pursue, and this is kind of a stepping stone to getting some better performance.
Tyson, when you were talking about this stuff, it reminded me of, I think this is a really interesting feature, and I think developers would really like it. And another feature I hear serverless people asking for a lot is to be able to restrict the number of activations like going on within the platform for particular actions. If you've got like a downstream service that can only take like 100 activations concurrently, you often don't want your action to be able to do that. And Lambda recently announced kind of per action, per function limits. I think when I've asked about this before, Roderick explained that they didn't track like concurrent, activations across like on a per action basis. They didn't have the capability. And I wondered if you were going to add this feature. It sounded like you might need to be able to do that, and whether that would open up the possibility of having a similar feature of like per action activations and having limits on that, and make that simpler to implement in a platform.
Yeah, I think that feature is kind of an analog, but it's separate. So this feature is more of when a container is available, how many activations can flow through that single container. And that feature that you describe is how many containers are possible to create. So I think in order to do that is a more challenging problem inside of OpenWhisk, because there's that the state of the invokers, or the state of the container pools more specifically, is not shared anywhere. And that's what that would require, because you would have to say this container pool over here has one container, and therefore this other container pool cannot create a container. So yeah, I think there's some additional complications with that type of feature. Okay, that's good. Thanks for explaining. So this was excellent. Thank you. You've done a good overview. For someone who's not deep in the platform code, this is really good. I think there's lots of discussion that's come up that we could probably take to the dev list and give people. I have some more feedback around developer experience stuff, but let's take this offline because we're running a little bit short on time. So thank you, Tyson. That was awesome. Thanks. Let me jump back to, I think if I share my screen. So we'll just quickly, in like hopefully 5 minutes, kind of run through if anyone has any updates for other bits of the project. Literally you've got like a minute each, so be terse. Has anyone got anything to say on the release process?
Matt, here, I'll just give a brief update. Vincent's and our team is working on that. So again, if you look on Apache CWiki, you'll see we have a maturity model now. So I think the first thing I'm trying to do is make sure that we have references and docs and markdown and things that describe what we're doing in terms of decisions made around licenses and notice files. And we'll start filling out the matrix. We'll start asking for help for people at large in the dev list to help fill out and review the matrix. If you go to the release repo, the docs are improving. We actually have a list of all of our policies about which files need license headers and why certain files by type or whatever are exclusion. We list our exclusions. So things are really shaping up in terms of being able to go in front of the Apache board and say our release is up to your policies and processes and things. So that's the goal. That's great. That's great. Thank you, Matt. Does anyone have anything to say about Mesos and Kubernetes stuff? Again, very briefly in like 60 seconds.
Okay, yeah, this is Dave. On the Kubernetes front, there have been basically two things that have happened since the last call. One is we've expanded the matrix of combinations of Minikube and Kubernetes version we're testing in Travis, and that's useful because not all versions work. And the second thing is we got a big contribution of a Helm chart that sort of sets up a core OpenWhisk system last week. And I'm working on extending that and trying to get that to go through Travis as well. And there's some minor annoyances there because we're still stuck on Trusty. And so maybe a question that's maybe an offline question is it possible to get a Xenial Ubuntu image for Travis CI or not? Because I keep on having to install more stuff to deal with the really old images.
All right, that's a good, maybe someone can answer offline, but that's a good, thanks Dave, that was a good update. Anything on Mesos that the Adobe teams want to share? Otherwise, I'll move on. No, we were just keep on moving. I think one brief discussion that came up on the Slack channel was at some point we need to figure out a resource advertisement and request ability for action developers. So if you develop an action that ideally runs with a host that has GPU access, how would you do that? And so
I think we have the same kind of desire to do that, and I think Ben was mentioning that on the Slack channel. So I think we'll start pursuing some ideas around that in the near future, but nothing yet.
I think that would be an awesome feature. So yeah, all right, that's definitely cool. API Gateway, does anyone have anything to say about the API Gateway? I don't even know if there's been any work in that recently, but
I could quickly jump in.
Yeah.
I think something that I got into recently, like last night, is the ability to sync the gateway configuration from a remote folder, which includes Amazon S3, Google Cloud Storage, even IBM Cloud Object Storage, Dropbox, etc. I think this is particularly useful for kube and Mesos deployments where you want to update the gateway without disrupting the traffic. And probably for our next intercall, I'm going to show how that can be used with the Whisk API create command and have a slightly different implementation for that.
That's good. I saw someone open an issue or something around the Docker Compose with the API doesn't work if you use Docker Compose to spin up the platform.
Yes.
Could you very briefly explain why that is, and is there anything we can do?
Yes, I am actively working on this, and I think in the next couple of weeks we're going to get alignment here, and Docker Compose is going to work as well. Yeah.
Awesome. That's good to hear. Okay. Final two catalogs. Is anything going on the catalog? Anyone wants to share?
You may notice, Pretty's on the call, but she's been working to create Whisk deploy manifests for some of the, starting with the utils package. We have a Whisk-based deploy option for those packages. So
good.
That's awesome.
Nice. That would be good. That would be really good. And then tooling, I guess we've maybe just talked about this a little bit, the dev utils and stuff like that. Is there anything else anyone wants to share about tooling stuff, dev utils? Speak now, forever hold your peace. All right, that's good. Silence. Okay, let's move on then to, it's going to be a final presentation. Michelle's going to talk about some of the awesome work he's been doing on the new Go handlers, which massively improve performance for some of the actions. So yeah, so this is going to be cool. I'm excited to hear how things are going. I think it's almost, or has just about got into the project. So Michelle, let me stop sharing my screen. You've got about...
I share my screen.
Yeah, 13 minutes. We need 5 minutes then just to do
I try to make as short as possible. Anyway,
yeah.
Yes, okay, yeah. We are running late. This I'm talking about the new runtime for Go's with binary. Last presentation was mostly the presentation, the introduction. Now, from my point of view, the implementation is complete. So I'm handing over. And so shortly, what is it? Is a new runtime that at the beginning was born for support to Go actions that was designed to be more efficient than the Docker skeleton. Because at the beginning, the Go support was managed using Docker skeleton that basically was starting a new executable for each request. It does remind me the CGI that were not very efficient. So I proposed a new implementation based on something very obvious, something that I call the action loop. So basically, an action is kept running, the binary is kept running, and will receive for each action an input that is serialized JSON. We'll analyze it and will return another output that is another line of a serialized JSON. Then this symbol thing has been extended so far to support actually generic binaries, not just simply Go actions. And then I implemented a combination of Go actions in source code. So it was in part of other runtimes like the Swift one, where you can actually submit a source code and have it compiled on the fly. This has been used also to support Swift actions that are providing better performances. And now this is a new feature that I called using the images, the runtimes as compilers for offline compilation to solve the problem of the warm startup. But let's go in order. So this is a quick reminder of why of the action loop. Basically, in efficiency. At the beginning of the project, I did a quick, quick and dirty, but realistic the performance test, and I found that the Go action implemented as an action loop are 500 faster than the Docker scaled implementation. I did the same test for Swift, and they were 250 more faster, so definitely that was the way to go. And that's it, the action loop. They updated the action loop.
Hey, Michelle, sorry to interrupt. I don't think people can see your screen. They can see, we see you.
Can you see the screen?
I can only see you.
Sorry.
That's all right.
I wanted to share the screen. Can you see the screen now?
No, not for me. I still see you in full screen.
Share screen. Desktop 1. This is
okay, here we go. Here we go.
Can you see?
It says you started sharing. Yeah. There we go. Yeah.
Sorry. So basically, you lost the first, and you watched my face instead of the slides. But okay, that's fine. So that's the important one. So this is the action loop that is in the original way. The original design of the protocol was getting the input line by line in standard input, and the output was sent in standard output, and the log was sent in standard error. But then there was a problem because Swift prefers the standard output for log. Go prefers the standard error for log. There are some inconsistencies because Node.js use sometimes the bot use the standard error and standard output. So in the end, the protocol was revised to put the output in the file descriptor number 3, while standard input is the file descriptor number 0, and the log is both in standard out and standard error, that is the file descriptor 1 and 2. So the new action loop protocol is just this, no more than this. The action loop is a very simple idea. You have to publish a binary that will loop on reading one line of text in standard input, the code it as JSON, execute the action based on the input, log is standard out to the standard error, and finally output is in file descriptor 3. I said why it's mostly for compatibility, why I'm using the file descriptor number 3 now. This works for any binary. It's basically very similar to the idea of Unix pipes. It's actually implemented using pipes under the hood, and is high performing because there is no startup. This is done only once, the startup. The binary is kept running, and is keep reading input, writing output. So it's pretty much efficient. And a very interesting thing is that the action loop can work perfectly using Bash in an efficient way. Actually, I did a quick and dirty test, and looks that as fast as Go. so it's pretty because most of the overhead is not happening in the execute in the code, but in everything in the runtime, in the network connection, in many other places, but not in executing the code. So this is a very simple example, and I support also now any executable that in Unix term, an executable can be any script. So you can anything that implements this action loop protocol can be used for the images, and it works also with Bash scripts. So this is a very simple example of a Bash script doing an action loop. So it reads line by line, then it passes the JSON and using the JQ utility to do that, and then finally I do log just echo in standard error, and finally I produce the output. So the trick is to send to the file descriptor 3. That's all you need to implement this so-called very simple protocol. But in practice now there are 3 images. The base images, that is the action loop one, that is the Go proxy that implements this symbol protocol. That is the idea is can be either a replacement or a complement for the current Docker skeleton. Actually, I played with it and I was able to use it also for an Haskell example. So it supports any generic binary. And see if we document the protocol is a generic support for any type of binary. And then I have used it for implementing the Go languages support and then Swift support. The Go language, the difference of Golang and Swift is that they support also sources. While the actual loop only supports binaries and scripts like bash shells, bash shell scripts, the Golang supports also source binaries, so it's able to compile them on the fly. And the Swift supports the Swift binaries. Actually, the Golang implementation is my own, while the Swift implementation is the proxy, and I reused the code that was already there, written by Carlos, and I replaced so I would say 90% of the Swift support is the old one, just replacing the proxy. The old Python one is now the new Go-based proxy. So those are the two quick examples. You can send as action this snippet of Go and this snippet of Swift. They are compiled on the fly. They produce a binary. So the two binaries can compile those actions. But an interesting thing is that since I had to implement a compiler, compiling using the images, an idea was if we could use the images as compilers. And that's actually pretty easy, because all you need to do is using Docker, I decoupled the compiler from the proxy, so you can use the images for compiling the binary. So the idea is that we can use this in tooling like Whisk deploy or Whisk itself. I don't know. I think Whisk deploy is a better place to do this step. So you can decide that you can precompile the images using the images itself, or you have to Docker installed. This will avoid the problem that compiling the action on the fly is pretty slow. So you will precompile the images. You can do only once when you have finished your work, and send this for production, for having the images optimized without having the problem of the slow warm start. That's all basically.
That's very cool. I think this is awesome. Thanks for the hard work on this. It's very exciting to see. I would love to. I know you have some performance numbers. I think when this is all merged and all documented and all that kind of stuff, it'd be great. To do.
Everything has been. I wrote all the tests.
Awesome.
Let me check that.
It would be good to do a blog post or something just to highlight this awesome new performance improvement and talk about some of the great engineering work.
Okay, sorry. So far, I sent the patch for the proxy. There's the patches for the Swift actions, and the a test suite that is in the main incubator. So everything. So from my point of view, I have done all I had in my to-do list. Now it's time to merge. Of course, there will be things to fix.
Yeah, we'd love to support this in Whisk deploy, or just remind us, open an issue, and we'll put it on our log.
This is something that we have discussed in the past. We gave them different names. We call it init actions. We call them builder actions. So basically, it's tooling that you can use OpenWhisk to compile your OpenWhisk actions and actually use OpenWhisk to deploy your actions. That's kind of the nirvana, eating our own dog food. We have the deploy package out there, but yeah, deploy package, Whisk deploy, that area of user land is where the compiling is. Today we have some of that for Swift, but it's kind of a script. But this one is more robust, I think. So this is good.
Well, actually, my idea was to add to Whisk deploy a sort of another action or another entry that can be called precompile.
Yep.
And this one can be invoked, whatever. That would be useful, for example, to zip Node.js action, because one main problem of with deploy is that I have to prepare the zip and then. So if I just add just a precompile action that it can do whatever, compile the image action, precompile Python, collect precompile Node.js, and that's a small change actually. So this is my idea.
It's applicable.
Very cool.
It's applicable to Node.js also. One thing that people tend to do is build their zip their Node modules in their laptop instead of using or doing npm install in their laptop instead of doing it in the runtime in the Ubuntu. And if there's binary modules for Node, guess what? They don't run, and they get errors. But yeah, that's good. One quick question I had was, why is there any reason why we can't start with Go 1.10 and skip 1.9?
No reasons. I just I put 1.9 because it's widely used, and the 1.10 is pretty now. It's pretty recent, pretty new. That's the only reason. Actually, I was thinking to put 1.5. That is the widely used, but in the end, the area is backward compatible, so probably we can use 1.10. It's not an issue. All you need to do is change the zip you download. But I have tried so far. I never have problems with all the version I use. There's 1.5, 1.3, 1. I never had the problem with any version I used.
Yeah, might be. We can discuss that offline, but it might be good to start with 1.10, and this is just to, help with the maintenance and the support.
One line of code changes.
Cool. Yeah. Okay. Yeah, that might be.
You have to fix the epilogue, because I did the example of action loop without codable. But my Swift is not good enough to implement properly. So you have to complete the implementation of the that's the only thing I was unable to do.
Yeah, I can handle the Swift, and then I'll merge the other stuff. And then we'll put it on top and then continue until we feel confident. And like James says, do a blog post when we feel confident.
Another thing,
send people now to the far pitch.
Another thing, please, if I split again in multiple patch,
no.
Actually, the patch is big only because I rewrote all the tests in Go. But I was saying the 90% of the patch are just tests. The only important thing to review are the change of the code. Are not too many. They are mostly added support of compilation and multiple mines. Everything else is already reviewed. So don't again the loop of splitting patch and never finish to merge.
Yeah, okay. I was already testing the big PR in my laptop, so I was already doing it. So
okay. Yeah, okay. I did a lot of tests, a lot. I tested in every possible way, and so I think the quality of the testing should be good.
Good. That's good. Thank you. No, it's exciting to see. And thanks for the presentation. It really helped me understand how it worked. So we're almost at the top of the hour, so we've got 2 minutes left. Before we pick the next call, has anyone got anything else? You've got like 60 seconds. So if anyone has anything else, say so now. Otherwise, we'll get on to picking a speaker. Nothing. Okay. I have something actually there's a conference series around serverless called Serverless Days. I'm involved in organising the London event. So if you would like to come and speak about OpenWhisk, the CFPs are opening. It's going to be in London in July. I've probably booked people, so I'd love to get more OpenWhisk talks. If people have stuff, let me know and we can get a submission in. And there's going to be lots more events in this series around the world. So get your OpenWhisk talks in and kind of advocate for it that way, because otherwise it's going to be very Lambda heavy, which is not what we want. Okay, 1 minute to go. So let's pick someone. Would someone like to do the call in 2 weeks' time, right? If you haven't done it before, that would be wonderful, but maybe we're getting to that point where everyone's already done it once. Has anyone not hosted the call before? See, now everyone gets very, very silent. Roderick, since you're not an IBMer anymore, do you want to host the call? Now you're an external community member. Silence from Roderick. Roderick, are you still there? You dropped off. I think he's gone. All right, never mind. That was a good. He's like, I'm out of here before I have to host the call. Okay.
I could take it if there's no newcomers that want to step up.
All right. I think it's just as old timers on the call today, looking at most of the people. So yeah, why not, Tyson? You can. Thank you. You do that. You have the honor of doing the next one in 2 weeks.
Oh wait, Dragos is just warning me that I'm out of town. Yeah.
Is that like that thing when someone rings you and go, I gotta go. I gotta go right now.
Is that like, oh yeah, that's right. We have a speaking engagement on the 9th. Oh, I'm sorry.
It's very convenient. Okay, all right.
I forgot.
Let's see, who else can I pick on? Andy Steed, do you want to do it?
Not sure what it entails, but sure.
I can set you up, Andy. It's easy.
I mean, you've just seen me. This is all it is, basically. You just have to, a couple of days before, ask people if they've got agenda items, let people ramble on and hurry them along, and then and that's it. And you have a dutiful note taker, Matt, who will do all the hard admin for you. So
also for agenda items.
Yeah, just bug people to ask what they want to talk about. So cool. All right, thank you. Good volunteering. Thank you for being volunteered.
Yeah,
all right, we're at 5 o'clock, so we're out of time. Thanks everyone for coming. This was a really good call. Yeah, see you on the Slack channel, see you on the main list, and talk to you all in 2 weeks' time.
Thank you.
Bye-bye.